In this video lecture, we're going to continue to look at some constructs related to bash scripting. We're going to specifically look at how to deal with numbers and how to loop through a number of items. This will give us the power to operate on a large number of files at one time. So let's start by looking at one command that we're going to use to demonstrate the loop for our first example. So first off, I'm going to use the command seq, S-E-Q. And what SEQ does is it just basically prints out all the numbers that I tell it to up to the option that I enter. So in this case, I entered 10, and you'll notice that it printed out all the whole numbers from 1 through 10. And, you know, seq actually also allows me to do like 5, 10, which would only print out 5, 6, 7, 8, 9, and 10. So what's really cool is seq is a command that exists within the shell to allow us to print out a sequence of numbers. And so you can actually look at the man page and see you can increment by 2 or 3 or 4 if you want, or whatever you want. So it's a pretty helpful command. So how are we going to use this? Well, I have this script here called loop.sh. And before I run it, before I edit it, let's go ahead and run it and look at what it does. So the script itself is not executable, so I'm just going to pass it to bash to interpret what's in there. And what you're going to notice is it does pretty much the same thing that the seq command did previously. But in this case, you'll see that the only difference is there's this little string here in front of it called value is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so we're just going to use this example as a way to look at how we can deal with loops in bash. And again, loops are just a way for us to do something over and over and over and over again. And actually what's great about that is, I mean, computers are so good at performing repetitive tasks. Anytime you have a task where you feel like you're doing something more than once, it's probably a good candidate for a shell script. So let's take a peek at our script here and talk about what it does. So I've got my first line here, indicate what interpreter will be handling this file. In this case, it's bin/bash. And now we're going to look at some new syntax. And this is what a loop looks like in bash. And so essentially what this is going to say is, I want to do this item here between this, the keyword do and done. Anything I put between those two words will get repeated over and over and over again. Well, how many times will this get repeated over and over again? This many times. And what does this say? Well, if you've never done any programming, this might look a little bit strange. But if you have done programming, this is very similar to a for each loop in many modern programming languages. So what's going to happen is, let's start to the right because we can see some things that we've seen before. You'll notice that seq is the command, and 10, when we already saw this before, this will print from 1 through 10. You'll notice that this is inside of a $ parenthesis, and what that means is it'll go ahead and execute this command and then grab the information that would normally go to standard output so we can do something with it. And what this will do is it will grab each line of text in turn, one at a time, and then put them in this variable called I. And so this is actually a variable. And in loops, again, if you've never done any programming, I tends to be the de facto variable used. It's not a requirement, but it basically is just stands for an iterative or iterator. You know, another word for looping is to iterate. So in this case, we tend to use I a lot. So what's going to happen is, the first time this runs, it's going to print 1. It's going to take the value 1, put it inside of the value I, and then what's really cool is, remember when we assign to a value in bash, right, we don't use a $. So the first time through, it's going to assign I to be the value 1, and then the second time through, it'll make I2, and I3, and I4. But it's going to do that all behind the scenes and automatically for us. So the first time through, and this construct is smart in the sense that it knows that this command will be outputting, you know, some possibly infinite number of lines, and that it should just go through one line at a time, take the value that's produced by this command and store it into this variable. And so what will happen is, the first time through, the value 1 gets stored in here, and all I'm going to do is print it out. And you can see the $I here. And to stick with previous conventions in video lectures, we can also go ahead and put in the curly brackets so we can make it even more obvious that in this case I am reading from the variable I. So here I take the number 1, put it in this variable. Down here I work with the variable I, print it out. And then what happens? Well, if there's still more stuff to work through, this loop is smart enough to go back up and keep going. So this loop will continue until it runs out of stuff to do. And if we exit and we run this again, you'll notice that the sequence command normally prints out the numbers 1 through 10. So that loop is going to go 10 times, as we can see it here, and all it does is simply grab those numbers each time through and prints them out in such a way. So if you've never seen loops before, this can be a little bit strange. Why am I printing out numbers in a row? Well, just to kind of show you and demonstrate how this works. But there's usually some more important things we can do. So I don't know what directory I'm in, so let's take a look. All right, so I'm in my desktop directory. And if I do an ls on this directory, you'll see a bunch of files that I've created over the period in time that I've actually been building these video lectures. And sometimes what you want to do is you want to do something to every file in a directory. And so it can come in really handy to use those loops. You might say like, oh, hey, well, there's 1,000 files, and I need to change their names from .htm to .html, right? Maybe you're cleaning up a legacy website. Or maybe, you've got a bunch of files that are named doc, and they should be named docx. That's a really simple example, renaming files. Maybe you have a bunch of files that have the wrong owner, and you want to loop through and do a chmod on every single one of the files that you find. Maybe somebody's name changed, so that's a possibility, and so you change their username, and now you want to update all of the files that are related, but keep the old username around just in case. So it's a couple things that you sometimes want to do a bunch of work on a lot of files. So what we need is a way to feed this ls-l input into our loop. And what you'll notice is if I try to do it this way, so let's go back in and edit my file. And if I say, okay, well, here's what I'm going to do. Instead of doing sequence, I'm going to put an ls in there. So let's go ahead and run this. And what you'll notice is that is actually smart enough to go through each of the items in this command output and print them out line by line. And you'll notice that before I said, well, wait a second, an ls doesn't come out on new lines. But the loop construct is actually using these spaces between the file names to break these items up. And so it's taking each of these components and it's going ahead and putting them into that variable I and then printing them out. So anytime we have a command that will spit back a bunch of information, multiple pieces of information, we can use a loop to grab that information and then programmatically act upon it. I would normally not write the script like this. So if we go back and edit this, the only change I would make is there's actually a thing you can do with ls called -1. And if you execute the ls command with -1, it basically gives you an ls listing where each file in the directory is put on its own line. So you'll notice that previously this script worked fine before because it used the spaces to parse the different components. But in this case, I kind of like using -1 because it'll just put each file on its own line, and it just makes it a little bit easier to understand specifically what's happening in my case. Other people may disagree. So if we run that, you'll see exactly the same difference. And actually, you know what? I'm going to clear this and then run it. So you'll see that we get the exact same output, but in my opinion, the script itself is a little bit more readable. So let's say I want to do something to everything in this directory. You'll notice that I'm in a couple of groups. So let's say I want to go through and I want to change every single one of these files group ownership to CD-ROM just because I can. And we'll see if I have the ability to do this. What I could do is go into my script, and instead of printing the file out, what I can do is still use that variable as input to a command. So if I wanted to, I could say, okay, like I want to chmod or ch group chgrp. Early day here, and go ahead. And what I want to do is pass to that the name of the group, and we'll see if it works. And I should probably just type it in and not keep arrowing up. And so what you'll notice is it executed this command a bunch of times. And notice nothing changed. Why? Because I left the echo command in there because Again, it's an early morning, even though the clock says it's not. So I need to get that out of there. And actually, that's a good error. Like, I don't mind leaving some errors in like that because it's a Unix is one of those things where you kind of need to make sure you're on the ball when you're working with it. So let's clear this. Let's execute that. And you'll notice that it was unable to do that. But if I do an ls-l, it actually changed the group of all these other files. I got one error for this specific file in the change group command, but I was able to go through and change the group of all the others. And if I want to change that back, I can just go ahead and re-edit that file and change it back to JSON. So you get to see me debug a script a little bit, get to see how useful this can be. And again, I still get that error. We could deal with that error, like we could redirect that error if we don't want to see it in the script itself. We could, log it, we could do whatever we want, but I think it's fine having that print out to standard error. So you'll notice that we're back to where we were. So that's the basics of utilizing loops. And one of the things that you could do with a loop as well, you'll notice that in that case, it went ahead and also did directories. Well, in a previous lecture, we talked about using if statements. So you can put any valid piece of programming in here between the do and done. So if you wanted to, you could loop through each file, put an if statement in here and say, okay, is that file I'm currently looking at a directory? Or is it a plain file? And if it is a plain file, change its group permissions. If it isn't, don't do anything. So this is the basic concept behind loops. This is really powerful, and you can use this for lots of things. So anytime you find yourself doing the same thing over and over again, stop, write a script, try to automate it. Bash also gives us the ability to perform arithmetic. Now, by default, in Bash, you can only do integer arithmetic, which means you can only deal with whole numbers. There are some workarounds to deal with floats, in other words, decimals that have a fractional or decimal numbers or numbers that have a fractional component. I just won't discuss those in this lecture. If you do a Google search, there's some good opportunities to see some creative ways to handle that. But that's beyond the scope of this lecture. We're just going to take a look at basically how to do simple math. So in Bash, we'll just go from the interactive command line for right now. We saw before that if we do $ parenthesis parenthesis, we can put a command in there, and we will get the output of that command. There's another construct in Bash uses double parentheses on each side, and when we put items inside of the double parentheses, it will perform math for us. So you'll notice that the difference between single parentheses and double parentheses is that one looks to execute a command, single parentheses, and the other will go ahead and perform mathematical operations for us. So we can do typical addition, subtraction, multiplication, and division, which is really nice. So if you want to put any type of equation in here, it'll give you an answer. Oops, and I need to put 2 parentheses in there. And also think about the correct direction of my slash because I'm not dealing with a... Okay, so notice in this case, when I do division, if I divide 3 by 2. So, right, 3 apples divided by 2 people should give me 1.5. But notice that because Bash can only deal with integers, it does what's called integer division. So what this means is this basically only gives us the answer to this division operation, which would be the quotient. So in this case, we just get 1. If I go ahead and divide 4 by 2, I'll get 2. But if I also divide 5 by 2, I get 2 as well, because again, it only performs math with arithmetic, integer arithmetic. If you're not familiar with it, there's also another operator called modulus that will give us just the remainder of an operation. So the percent sign, if you ever see that in a mathematical operation, says divide 5 by 2, but tell me the remainder. So if I divide 5 by 2, I get 2 with a remainder of 1. If I divide 6 by 2, I'll get 3 with no remainder, so I get 0. So the modulus operator, if you're not familiar with it, we can use both division and modulus to get both the quotient and the remainder of a number if necessary. So any equation that we put between this $ parenthesis parenthesis construct is going to be a mathematical operation. And what we can actually do too is we can assign these to variables. So let's just make a variable called thing, and I'll assign 6 mod 2, so it should be 0. And then if I echo that $, notice that I get 0. So we can also go ahead and assign the output of this command to a variable and then use it later. So we can do some math and access that data later. So I have a script that integrates an if statement along with a little bit of math. And basically all the script is going to do is determine if a number we give it is odd or even. So I run the script, and as a parameter I'll give it the number 3, and its answer gives me odd. If I run it as 4, it tells me that the number I entered on the command line is even. So let's take a look at the script. So this is a standard bash script. We've seen this before. I got some reminders in here that we can't deal with floating point numbers. And so here's an if statement. We've seen that in a previous lecture. So we know that if the statement inside of these brackets is true, it'll print even. If the statement inside of these brackets is false, it'll print odd. So this is pretty much a straight copy and paste from a previous lecture. The thing of interest now is this piece right here. And so we just talked about the fact that anything between $, parenthesis is going to be an equation. And I know that a number's even if I divide by 2 and I get a remainder of 0. So if I can evenly divide by 2, I have an even number. So what I'd say here is if I divide by 2, and again, modulus will divide by 2, but return the remainder, not the quotient, and the number returned is equal to 0, and we'll look at where you can see all these, find all these different equality operators in a second. They're in the bash man page, again, buried deep in there. So usually a Google search will be quicker. But what this says is if you divide some value by 2 and its remainder equals 0, then that number's even. If you divide some value by 2 and its remainder is not equal to 0, then you can echo odd. You'll notice I've combined a few different features here, right? So we've got this new idea of working with numbers via this construct with double parentheses. But notice I've also used $1, and this is how I can access the number passed in on the command line when I run the script. So it's really useful.